Good morning, mathematicians. Welcome back. Welcome back. I shouldn't have bothered trying to do that algebraic topology problem through the groupoid pushout. I don't think that's the better way to do it, to be honest. Actually, the universal cover approach is way easier. I shouldn't have bothered trying to. Also, maybe today you'll get a behind-the-scenes look at the next semi-direct product video. Not the next one, but the one after that I'm planning to put out. Good morning, Edit Smith. Good morning. So let's talk about algebraic topology first and finally put this one to rest. Because yeah, here's the universal cover. Here's the universal cover. It's just I don't know. I can't draw it very well, but you take a bunch of you take an infinite integer copies of the real line, and then you glue these two, and you glue these two, and you glue these two. But you only glue it away from the origin, right? So, yeah, what's a good way to, I don't know, a good way to draw it? Be something like this, right? But then somehow this needs to be over there. It's kind of hard to draw, but do I have any introductory references on Shimura curves and modular curves by chance? You're getting into it for your thesis. You just found an overflow question and other things, struggling to find these. Yeah, to be honest, I don't have a good one. Yeah, I don't know a ton about it. My master's thesis was technically, I wrote blah, 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 some crap about connections to Shimura varieties in the introduction, but yeah, I just, I didn't really, I never personally learned that much about it. It was kind of always floating in the background, and it was just, I just put what my professor told me about, he told me, he's like, oh yeah, one day, this is connected to Shimura variety somehow, and that's why this is important. I'm like, yeah, oh, okay, I'll take your word for it. You're also in a library right now, so you can't hear what I'm saying. Oh. Well then Jonathan, actually let me do this then. Wait, did we make fun of you for asking AI for some exercises on Hartshorn? I thought I said that was probably reasonable because lots of people have uploaded solutions. I do know the channel Honest Taurus. I've liked some of the content I've seen. Yeah, Boris, well, I gotta say controversial stuff to get clicks, Um, um, yeah, but is that, I mean, is that what Honest Taurus is saying? I don't think that's what Honest Taurus is saying. I could be wrong, but that's maybe a little simplified. Um, but I could be wrong. Oh yes, yeah. People. That's what people were going after you for, Edit Smith. Was you saying you were trying to do 6 problems a day? I think that's what people were reacting to, not using AI. um. Yeah. Anywho, and then it's pretty easy. I mean, once you just make this, um, once you make this identification, yeah. What's the best way to do it? Almost like I glue those, and then but then this has to get glued. But like before the dot. What am I doing here? Anyways, the point is, okay, these get glued. These get glued. These get glued. And then it's not too hard to see that basically the deck transformations are just going to be shifts by 2. So like shift this line to here and this to here, and so on and so forth. Yeah. And so the fundamental group should be the integers. Yeah. Okay. But as a preview for what I'm working on, so spoiler alert, you should tune out if you don't want spoilers for like a month from now. But you're also asking, then how do you know if you actually learned it or not? From the like answers that it gives, yeah. Well, okay. I mean, I think there's probably more nuance to it than just, right? The Honest Taurus channel says AI is the future of learning math or something. Well, the or something is kind of a big thing in there. It probably it is. Probably AI is a big part of the future of learning math. Or will be. No, Boris, forget about Paul's question. Well, I will. Okay, maybe after this, I'll like open up Galois cohomology book. I mean, I know it's just supposed to end up being the. Well, I guess maybe it's just supposed to end up being the group cohomology of the Galois group. But then this is a profinite group. Actually, I talked with a friend of mine, and he showed me 2 cool ways to compute it. But I feel like it's not sticking. So maybe we'll start a series soon about learning Galois cohomology together on live stream. But I'll tell you about another group cohomology thing right now. Is I'm basically trying to determine the extensions, the set of, Top Chat. Thank you. Steroid, groupoid. Do those really rhyme? I guess so. Both end in oid. this weekend, I think I can give myself the space to work on some videos and possibly merch. So that's the plan anyways, just FYI. So basically we want to determine all the extensions between here and, this is given by the second cohomology. And one can actually view this in terms of by looking at the subcomplex of normalized chains. And it turns out that the image of the map of normalized chains is trivial. And so the second cohomology is just going to be identified with the normalized two chains. So in other words, normalized in this case means we're looking at a function from two copies of z mod 2 into z mod 4, where if we have 0 in either component, then the function returns 0. And so actually there's only 4 choices of function based on where it sends 1, 1. So I'll call f sub a the function that sends 1, 1 to a for a in z mod 4. You're just curious, or you're solving a problem and you're stuck and you need help. If S and T are sets and F is a function, then how would you show that for all subsets A and B of S, F at A is a subset? Well, you're trying to prove what? That F A set minus B is a subset of F of A set minus F of B. Okay, well, how do you prove that X is a subset of Y? What do you need to show? What's the formal statement? While I wait for your response in chat, I'll keep yapping about my other thing. And so, yes, and then there's also there's a defining condition that it needs to satisfy. It's not just a function. Oh, I guess if it's in the kernel, if it's in the kernel of the map. It turns out all of these are in the kernel. So the point is, to each one of these, we should get an extension, EA. You mean the subset symbol? I mean, the way you wrote it, this, you said that you want to show that this is a subset of this. That's the way that you wrote it. But okay. But it doesn't matter. So I still want you to tell me X is a subset of Y. What does that mean? What's the formal definition? What do you need to prove? So EAB is going to be Z mod 2 times Z mod 4. No, sorry, the other way around. And the operation in this case, because in this case, this corresponds to, I should say, actually, I also need to tell you which Z4 module. I'm imagining this is the class of examples where the quaternions sit in the middle. And that's actually when Z2 acts trivially on Z mod 4. And so this should actually be the example of GH plus KJ being equal to G plus K plus F of HJ, comma H plus J. And so we can see right away that E0 will simply be the direct product of Z mod 4. Yes, exactly. So in other words, you want to show that for all x, or maybe I'd like to use y, for all y in FA minus FB, you want to show that y is in F of A minus B. Right? So how do you begin that proof? How do you begin a for all statement proof? Tell me in the comments how you begin that proof. This will just be the direct product. Okay, so I convinced myself by counting elements that E1 will be isomorphic to Q8. I think E3 will also be isomorphic to Q8, just by counting orders of elements. So let's go ahead and check that. So we have elements of order 1, 2, and 4. Of course, we have 0, 0 in here. Yes, exactly. So what would you do next? So let y be in FA minus FB. What's the next step? Hello, Paul Maurice. Hello. So I guess we always know that this element will have order 2, and this element will have order 4. So now we need to check some of the other elements. So I guess we could check 1, 1. So 1, 1 plus 1, 1 will be 1 plus 1 is 2. We have 1, 1 in the second component, so we know that we add a 3 to it, and then the 1, 1 cancels out. And so we're left with, well, this will be equal to 1, 0. So we know automatically that that has to have order 4. Okay, well, I mean, so we have one assumption in front of us, right? There's really only one thing to do. Let y be in FA minus FB. Well, what does that mean? By definition, what does it mean to say that F is in Y in this whole set? It means two statements. So what does it mean that Y is in this set, FA complement FB? You asked Konstavich? Then, man, why are you even... why are you trying to ask me these things on stream when you're able to ask the paper? I mean, the author of the paper. I mean, by all means, keep asking questions. Keep asking questions here in office hours. But, He said that the two bases of that are coming from pullback of O2 tangent bundle. And the other one is the normal bundle contribution. Okay. I'll believe it. Okay. So, what else we got to check? I guess 2-1 added to itself. That's going to be, so 2 plus 2 will be 0. The 1 contributes a 3, so it'll be 3 0. So we know that this element doesn't have order 2. And then finally we check 3 1. So 3 plus 3 is 2, plus 3 is 1, 0. So, okay, so this one, I was right. This also has to be Q8. And so I'm pretty sure that E2 has to be the dihedral group. I think just by counting groups, because we know each of the isomorphism classes should show up. But I do want to just double check. So 1 0, 3 0, 2 0. Let's check 1 1. Matthias, what's it mean to be in the complement of two sets? What's the formal definition? So X is in, yes, there we go. Okay, I see. Right, exactly. So our next step in the proof would say something like, by definition, Y is in f of a, and y is not in f of b. Okay. So now things become slightly more complicated because we have a choice. We now have two statements that are sitting in front of us in the palm of our hand that we could choose to work with. Well, why don't we pick the first one that we wrote down? So y is in f of a. I mean, there's only two statements we can even try to do something with, right? We just have y is in f of a, and y is not in f of b. Pick one, and unpack it, right? So y is in f of a. Well, what does that mean? Think about what's the formal definition. What does it mean to say that y is in f of a? You've never used much finite group theory. It's always about continuous Lie groups. Yeah, I mean, I would say I also don't use much finite group theory. Actually, that's not true, because the stabilizers, the equivariant fundamental groups that come up in my work are finite groups. But yeah, I mean, I'm working with p-adic groups and stuff. Yeah, finite groups are nothing but zero-dimensional Lie groups. True. Yeah, and I think one could have have a perfectly fine time just studying Lie groups, but I do feel like if I had learned even more about finite groups and their representation theory, I probably would have had an easier time with certain aspects of algebraic and Lie groups. But it's fine as it is. You've been doing some equivariant homotopy theory, and mostly with finite groups. Oh, nice. Yeah. Yeah, I wonder. Maybe I'm tempted to yap about equivariant stuff in a moment, but okay. Because there are applications in theoretical physics. Yeah, makes sense. Okay, so in this case, we're trying to work out what E2 is. Not in the Lie group sense. There is no such thing. So 1 plus 1 is 2, plus 2 would be 0, and 1 plus 1 is 0. Aha, so this is order 2, and I think that's right. So we have 2 elements of order 2. We know that this has to be the dihedral group. Well, I need to make sure, I guess it's not abelian. I mean, of course, it has to be the dihedral group, just by the way group cohomology works. You got it, Matthias? This is enough for you to... Well, I'm still curious. I still kind of want you to tell me the next steps here. Can I help you notate a pretty complicated function? It yields the sequence and can be defined by the missing edges in the iterations of the Sierpinski rug. What are L systems? What's the Sierpinski rug? L systems. Okay, interesting. Sierpinski rug. Probably misspelled that. Sierpinski carpet. Yeah, okay. And the missing edges, defined by the missing edges. Missing edges. Who has beef with Lindenmayer has beef with Newton? Alvaro. Sorry, I missed Paul's message. What is my view on Alvaro bashing Newton on his channel all the time? Is he? I hadn't noticed. I guess I hadn't watched any. Well, Sawdust Crater. I mean, I just need to know. I just don't understand the. Your question. I mean, if you want me to help with your question, I just need to know how the what you mean by missing edges, what the definition is there, and then maybe I could help you determine. Like, I'm guessing what you're asking for is like a closed form formula for the sequence you talked about. Well, I don't know what you mean by a different way, Matthias. That just from the first assumption, you use that f of a is equal to y for some a and a, yeah. And since y Yes. Yes. That's correct. Yeah. Yeah. Most people look at the area of the rug. Sure. Yeah, isn't that the point? Area the area is 0, but what the but the diameter is infinite, or what? Yeah, the area is 0, but I guess the length of the perimeters is infinite or something. You've been treating various tilings and fractal curves like they're nets of edges. Yeah, again, I don't know that's a little imprecise. Can you give a technical definition? And you're treating horizontal edges like distinct objects from vertical edges. Okay. We might have to continue this discussion tomorrow, though, because I think I am gonna end office hours soon. Area tends to 0, but the number of edges goes to infinity. Right? That does make sense. That tracks. Yep. I see. Okay, so I guess I see. It's like about the number of edges here. So in the first step, is it just the interior edges? So like in the first step, there would be 2 edges. I do have an email. ktheorytutoring@gmail.com. It should be in the description of any of my videos, including this one. Yeah. A different one from your introduction to algebra class. Could you try showing that? I will not do that now because I'm about to go. But I would. You should start with some examples. That's always a place to start, right? Start with some examples written out by hand to convince yourself. Looks like SL2 moduli space removed some points with all that glitter. Yeah. The gif of doing you a disservice by not drawing black lines around the tiles. By N4ish. Yeah, so N1 there's 2 vertical lines, and then by N2 there's, what do we have? So there's 3, 6, 8, 9. So it'd be 9 times 4 vertical edges, right? Anywho, I really do need to end the stream now. So we'll continue this and other discussions tomorrow. Go prove some things.